So how to use functions in Go? The first thing we're going to do is the first demonstration is that you can create functions, assign them to a variable, and use them on the fly. Okay, so the topic of the day is how to use functions in Go. Okay, so remember to follow me on these social media platforms and watch my other tutorials. Okay, so remember, I've imported package main and FMT, and now we're gonna import math. So I want to import math because I want to use square root. Okay, I've imported FMT. This is how to import multiple packages. I've imported math. All right, and here let's just declare a function. Okay, we'll declare a function and use it on the fly. Okay, let's say the function's name is uh, use square root, whatever. Okay, so we assign it. We're trying to get the square root or use the square root of a function. Okay, so let's declare a function that finds square root, and this function will find the square root of x, and it will give us the result in float 64, and the function itself will return float 64. Okay, so this way, now we'll just do just a simple function. Math. There is a function inside this that gives you the square root of any number you pass into it. So it's called math square root. It's in every programming language actually, that particular function, and it gives you the square root of x, period. So this function is simple. We pass in x and it gives us the square, it returns the square root of x. But we declare this function and we automatically assigned it to this variable. So we declared this variable and created a function and assigned it immediately. So now we can actually do some printing. So print line. So we can now say use square root. Let's say we want to find the square root of 9. So if we run this function, it should output the square root of 9 to us because we are calling this variable as a function now. Okay, remember how we used to declare function? We write func with the name of the function. All right, but in this case we skipped the name. We just declared the function and then assign it to a variable. Now the variable behaves like the function itself. So if I come here, I can do clear and then run this file, and there is a bug somewhere in my code. It says on line 3 expected found math. Okay, so the simple solution is that these two are supposed to be on separate lines, something like this. So it ran, okay, just because we accidentally put these two on the same line, and of course the semicolon is not needed. So here the function correctly calculates the square root of 9. So let's look at another way to use functions. Okay, let's talk about closures. If you're coming from JavaScript, React, and JavaScript-based frameworks, you would have been already familiar with the concept of closures by now. But let's look at it in Go, just for the sake of new beginners. So basically, a closure is a function inside a function. So usually an anonymous function. So we have our main code. Let's define a closure first, and then we can use our main code. Okay, func. Remember that I can actually write this function above, doesn't matter. So I can do, this is a new function and we're gonna call it get sequence. Okay, but we want to declare another function too. So we're declaring two functions at the same time. The second one, we're just gonna call it func. It has no name. That's the closure, right? A function inside another function. Okay, so we're declaring two functions, get sequence, and then another function inside it. And now inside get sequence, let's just do a manipulation. So we are assigning it. So we're initializing I. So we're gonna say that I is equal to 0. Let me just write it here. I is equal to 0. Okay. and then we output something. So we say return, we'll call that function. So we are calling this function, and well, expect the function to return an integer. And what we do, we increment I. So we can say I plus equals to 1. This is the same thing as saying I plus plus, in case you don't know if you're new to programming. So we return I. So this is a simple, we declared the function func and then we returned it. This is where we defined it. All right, so when we call this, all it does is it increments I. Each time we call this function, this one inside of it will run and increment I. That's it. Simple function. Now let's use it. So we can say something like, let's declare a variable and we can call it next number. Okay. This variable, we can assign it to this function, get sequence. You see? So we declare the new variable and we're calling this get sequence. We assign this get sequence to this variable. From our earlier videos, you now know that this variable can now be called like a function. So let's print it. Okay, fmt dot println. In case you don't know, you really don't need math function. It's from a previous video I did. So print line. So we are printing next number. Because we assign next number here, because we assigned it to a sequence, it now we have, when we are calling it, we have to put these two brackets because it now behaves like a function, because it is a function. So we're going to call it 2 or 3 times, and let's run this code first. So I'm going to clear and run this code. What do you think it's going to print? Of course, you are right. It printed 1, 2, 3. Look at this. We started by 0, and then the first time we call the function I is 0, and we increase I by 1, and we print I. That is 1. All right, for this line. Then we call the same function again. I is now 1. All right, and we increase I by 1, making it 2. We print 2. That's it here. The next time we call the function, the same thing happened, and we print 3. But let's say we create another variable, next number 2, and assign it to the same get sequence function. And we do the same printing. So let's print next number 2 and see what's inside. Now, pause this video and try to imagine what this will print. Look at the code again. We assigned next number. We assigned the function to a variable, and then we call the function 2 times or 3 times, and it printed 1, 2, 3. We assigned the same function to another variable, and now we want to print the result 3 more times, and let's see what it will print. Okay, so first one printed. Sorry, let me clear the screen so it's easy. Clear. Good. So this is the first 3, 1, 2, 3 is this. Okay, 1, 2, 3. But also the second 3 printed the same 1, 2, 3, which means the value resets. Each time we assign this function, the value will reset, and then it will print again. So that's how to use closures. There are more complex ways to use it, but since this is a beginner tutorial, I don't want to go too deep. All right, let's look at another way to use functions. So for the last part of this, let us do something called methods in Go. And a method is in Go, it looks like a function, but it has a receiver, and the receiver is present to represent the container of the function. Forget all this drama. Let me just show you what a method looks like. So you have a function declaration, you have a variable, and you have another variable, for instance, however many variables you want, and then you can have the data type, and then you have another function name. Let's say football function name. Then you specify the return type, and then you write your function code. So this is generally the method to write. This is how to write a method. So what we're going to do here is to practicalize this as quickly as possible, and that will round up the functions method that we have. So here you have package main. We are going to use another package that is called math. So I'm going to add it. So make sure that when you're importing packages, they are in different lines in Go. So here in Go, remember to follow me in different social media channels. And here we're going to have let's declare the first function. Okay, let's declare a type. Okay, this whole method will be calculating the area of a cycle. So first off, let's go on, or maybe under, let's go on to declare a type, and this type we're going to call it cycle. You can call it anything, but since we are calculating the area of a cycle, okay, calculate the area of a cycle. Okay, so since we're calculating, we'll call this cycle, and it's of type struct. Okay, so struct is very important to know. Struct is somehow like an array. So picture this like an array. So let's define the contents of the array. The content is this is a variable. It contains x, it contains y, it also contains another variable we're going to call radius, and all of them are of type what? 64, float 64. So now we have described the struct. Okay, let's write a function now. All right, this function is supposed to help us calculate the area. So func, the variable name, let's call a variable name cycle, and this variable name is of type cycle. Remember that we declared this cycle here, so now we can use it as a type for this variable, the way you use float 64 as a type for radius. Radius is a variable, float 64 is a type of the variable. So this variable is cycle, and this capital letter cycle is its type. Okay, now we're going to declare another function called area, and that's the name of the function, and this area will return float 64. And let's write now the calculation for it. So we're going to return math.py. Okay, we are calculating, we'll pull up pi and multiply it by the cycle.radius. So this radius here, remember that this cycle is of type cycle. Okay, now using a dot we can access the contents. So we are saying cycle.radius will give us the radius, and cycle.radius. So basically in math, area equals to 2 pi squared, right? Pi r squared, yes, equals to pi times r times r. This is a math formula. That's what we're trying to represent here. So we pulled up pi from the math package here. So instead of typing 3.142 by ourselves, it's already in the system, so we just called it. Remember there's a dot here, okay, so it makes sense for you. So now you know how they did it inside this math package. They did it something like this. Okay, so we pull up the pi, we multiply it by cycle.radius. So we dug into this and accessed radius, whatever the value of radius is, times itself again. Okay, so this will return the area of a cycle. So now let's use it inside main. So inside main here, we're going to say cycle is equal to that struct that we declared, and now let's pass some values into the struct. The first value is that x will be 0, and then the second value is that y will also be 0, and then we can pass that radius will be 5. So this is how you pass values into a struct. So you fill a struct with values, and then we assign that into a variable we call cycle. Okay, so now we're gonna do fmt dot print f. Okay, have cycle area %sign f. So we're trying to print the area of the cycle. So I think I can rephrase this: area of cycle is. So we now pass in the area, cycle dot area. So let's look at how are we able to access cycle dot area, because here we declared this as a method. So now we're able to access cycle dot this area. So when we do cycle dot area, you see cycle dot area, it will run this function inside. So essentially cycle dot area will run this function. All right, now when it runs the function, what does the function do? The function tries to access cycle dot radius and multiply it together. So what is cycle dot radius? 0 times 0. Okay, so now I think we understand how it works now. The radius is 5. It will now be 5 times 5 times pi. Okay, so let's run it. I'm gonna do a clear, and then we'll run main.go, and boom, there's an error somewhere on line 12. Syntax error, unexpected colon in argument on line 12. Unexpected colon in argument. Okay, I think I seen it. Inside main, so we have cycle. Okay, yeah, this is supposed to be curly brackets and not clear. And boom, it does the calculation and it shows you the result. The area of the cycle is 78.xyz%, which is what we have here. The area of the cycle is this. So I hope it kind of makes sense to you how to use struct. First of all, you define it using the keyword type. You type your, call it whatever variable. Structs is usually advised to start with a capital letter, so you don't confuse it with any other variable you create in the same name. You see? So see you in the next video, where we go to scope rules and string manipulation in Go.